This is Chandra Chemistry online chemistry class. In this session, we are going to discuss about atoms and molecules, Unit 7. Today's discussion topic, atom and atomic theory of matter. First of all, we want to know about matter. Matter is any substance that has mass and take up space by having volume. All everyday objects that can be touched are ultimately composed of atoms, which are made up of interacting subatomic particles, and in everyday as well as scientific usage, matter generally including atoms and anything made up of them. So, matter is any substance that has mass and take up space by having volume. Matter exists in various states, also known as phase, that is solid state, liquid state and gaseous state. So, atoms are defined as the basic building blocks of matter. It is the smallest constituent unit of matter that possesses the property of the chemical element. Atoms do not exist independently. Instead, they form ions and molecules, which further combine in large number to form a matter. So, atoms are much too small to be seen. Hence, experiments to find out their structure and behavior have to be conducted with large number of them to form a matter. Now we are going to discuss about atomic theory of matter. Early in the 19th century, John Dalton developed atomic theory. His theory explained the best available experimental data at that time. His theory has been modified since then with the discovery of other data, but his work was the initial groundwork that we will explain first. Okay, so first we are going to study about postulates of Dalton's atomic theory. All matter is composed of individual atoms. An atom is an extremely small particle of matter that retains its identity during chemical reactions. All element is a type of matter composed of only one kind of atom, each atom of a given element having the same properties. Mass is one such property. Thus, the atom of a given element have a characteristic mass. But in 1897, British physicist J.J. Thomson conducted a series of experiments that showed that atoms were not indivisible particles, but instead made up of smaller particles. From his experiment, Thomson calculated the ratio of electrons mass, that is ME value, to its electronic charge E. Next, Robert Millikan obtained the charge on the electron also. So these two discoveries, that means Millikan and Thomson experiment, combined provide us with the electron mass is 9.109 into 10 power minus 31 kilogram, which is more than 1800 times smaller than the mass of the lightest atom, hydrogen, thereby providing that the atom is made up of smaller particles. This experiment shows that the electron was indeed a subatomic particle. So, that is lead to the nuclear model of an atom. So, scientist Rutherford put forth the idea of the nuclear model of an atom in 1911. Rutherford's famous gold leaf experiment gave a good idea for the mass of an atom was concentrated in the very small nucleus. Positively charged alpha particles were deflected at a metal foil. Only 1 by 8000 were deflected, indicating that the nucleus was extremely small and positively charged. because the alpha particles are deflected. Only those alpha particles that directly hit the nucleus were deflected. The rest passed through. Therefore, he concluded most of the mass of an atom is in the nucleus. However, the nucleus is occupy only a very small portion of the space in the atom. The diameter of the atom is approximately 100 pm, that means picometer, while the diameter of the nucleus is approximately 0.001 picometer. That means if an atom was 3 miles in diameter, the nucleus was only a small size of golf ball. The nucleus of an atom is composed of two different kind of particles, that is proton and neutrons. Protons carrying positive charge, neutrons carrying neutral charge. An important property of the nucleus is its positive electric charge. This is the model of an atom. The center part is nucleus. These experiments shows that the atom is consist of two kind of particles. A nucleus, the atom's center core, which is positively charged and contain most of the atom's mass, and one or more electrons. That means atom is consist of two kind of particles. One is nucleus, another one is electron. Electrons are very light, negatively charged particle that exist in the region around the atom's positively charged nucleus. Nucleus, that is containing positive charge particle, that is proton. Electrons revolves around the atom's center core. Modified postulates of Dalton's atomic theory. All matter is composed of indivisible atoms. No, all matter is composed of divisible particles, that is protons, neutrons, electrons. An element is a type of matter composed of only one kind of atom, each atom of a given element having the same properties. Mass is one such property, thus the atom of a given element have the characteristic mass. No. Later found all atoms of the same element does not have the same mass. That is called as isotope. Atoms have different isotope that have the same protons but different neutrons and hence different mass. Finally, scientists propose the modern atomic theory. The main postulates of modern atomic theories are: an atom is no longer indivisible after the discovery of electron, proton and neutrons. These electron, protons and neutron is called as subatomic particles. So atoms are divisible particle, that is consist of proton, electron and neutron. Atoms of the same element may have different atomic mass. That elements are called as isotopes. Atoms of different element also have a same atomic mass. That type of elements are called as isobars. Atoms of one element can be translated into another type of element. That is called as artificial transmutation. Atoms may not always combine in a simple whole number ratio. For example, glucose C6H12O6, that is the molecular formula of glucose. That is consist of carbon element, hydrogen element and oxygen element in the ratio 6:12:6. Simple ratio 1:2:1. Sucrose chemical formula C12H22O11. Here the elements carbon, hydrogen and oxygen ratio is 12:22:1. 11. So, atom is a smallest particle that take part in the chemical reaction. The mass of an atom can be converted into energy. E is equal to mc square. That is Einstein law. Thank you.